Hi, so this is the problem of minimum multiplication to reach end, right? This is the problem, and if you see the problem, then our mind is attack something. What is minimum multiplication to reach end, which means we have to reach to end, start to end. So we can use here and in our mind to attack like a graph, first to end, source to destination, that type of the problem. Okay, so firstly we understand the, so given two integers start and end along with an array of integers array in one operation, you can multiply the current value by any element from array, and then take the result modulo 1000 to obtain a new value, right? Find the minimum step in which end can be achieved starting from the end. If it not possible, then reach to end, then return -1. The problem is very simple to say. We have the array, right? And this is our starting. The starting, which means we have to calculate from this, right? And this is the end. And the end is our target value, right? So now there is the array of this one. We just have to take here. Now what we have to do, I have to do like starting from this and then multiplications of the, and just multiplications. I just explain how and what is how, how it is. There is first thing is our starting is and also we take the start and end here, right? Now the start is our 3 and the array is first is 2. So what is our, so 3 into 2 and then 3 into 2 is equal to 6, right? And then 6 into 5, not 5 into 7, no? Then 6 into 5 is equal to 30, which is our target value. Means we have to match the end value. So here, and we can do multiplication till we don't have got the end. There is any chance to find the end, then we will return that counts, otherwise return -1. So the count is, and there is answer is equal to 2. Why? There is need of 2 operation, then we have to, then we will get the 30, right? So this is now in that the problem, if you understand, the problem says that we are given array and a starting index number and target number in it, right? In one operation, choose any number from array, multiply current value with it, and take modulo 1000. If we will take the modulo of 10,000, the reason is behind we have to always return the answer of 0 to 999, not more than, right? So this is, now I just explain the approach, what you have to approach. In that, think of every number from 0 to 999 as a node, right? If from node x we can get to x into, if node x, we can go to, right? And then x into array of I mod of 1000, right? Then there is an edge. Since every operation cost 1, we need shortest path in unweighted graph. Best algorithm is BFS, and then approach 1 is BFS optimal. Why BFS? BFS always find minimum number of operation in unweighted graph. What is the algorithm says? The algorithm says that the first step is start BFS from a start, and then try multiplying with every element. And the third one is generate next state, and the fourth one is if not visited, then push into queue and mark distance, and then fifth one is stop when end found. Stop when end found. That is the steps and algorithms, right? Now I just go and write the code here to our thinking approach, right? Like this is now start from the very minimum edge case. The edge case is what we have the edge case. If start is equal to end, then return true, return 0. Why? These are first element, then why we need, then there is no count. Now vector int, we have to take the one space vector int distance of 1000 to in max, right? Now q int, now q first is pair and then int and then int q, right? Now if we have to, and in the BFS breadth first search, which means step by steps, layer by layer, level by level, so in that we have to use the queue. Why? Like the first thing, the first that means the first layer will cover, then we store in the queue, and then for a queue says that first come first out, and then the first element is 5, then we just have to go and the and the all of the child node will traverse from the of the 5. So that's the reason we can use here to the queue and to the queue in the BFS approach and the BFS algorithm, right? Now there is while q dot empty, then auto it is equal to q q dot front, right? And then q dot pop. Now int node is equal to it dot first and int steps is equal to it dot second, right? Now for auto x2 array, and then int num is equal to new node into of a node into x modulo of 1000, right? And if steps plus 1, then dist num, then dist of num is equal to steps plus 1. If num is equal to end, return steps plus 1 and q dot push num steps plus 1 and then return -1. Now see it will turn or not. No, the problem is okay. So just analyze the where our code is wrong. So start from this here, right? Yeah, see the problem is like after the queue I will not initialize the q dot push back push of start to 0 and dist of start is equal to 0. So this will not do here. I think for that the error will occurs. Yeah, and try to submit. Yeah, it will submit it. So this is the problem and this is the approach of BFS, and in that the time complexity there are at most 1000 stats, right? So the every stats we try all elements, like order of 1000 into n. So where n is equal to array of size, right? So the space complexity is 0 of order of 1000, which means the time is order of 1000 into n and space is 1000, right? Approach 2, we can use the Dijkstra alternative. Dijkstra, which means here we can also solve the using a state is equal to node each edge. I will just explain as a Dijkstra approach. Dijkstra approach, right? In that, a states is equal to nodes and each edge weight is equal to 1, right? But BFS is simpler and faster for equal weighted, and Dijkstra is also same. The time complexity is in Dijkstra order of 1000 log 1000 into n, slower than BFS, right? So thank you. And if you ask the why DFS not work here, so DFS explore deeply first, right? If does not guarantee minimum operation, right? DFS may take long path even if shorter exist, so BFS is not suitable, right? So for that reason, so thank you for saying till the end. I hope you will definitely understand, and if you're in mind any other approach occurs, please note down in a comment section. Thank you